Hello guys, today is the second episode of today's oh my god, not today's but the series of completing the syllabus. Okay, here today we'll be doing the four operators. You know your four operators, the simple plus minus times divide thingy. We use BODMAS, BIDMAS and PEMDAS to know in which order do we do these operations. Why do we use BODMAS, BIDMAS and PEMDAS? This is a typo. If we did not follow like a set rule, example, 6 divided by 2, 1 plus 3. If we did not follow like our BODMAS rules, we do not know how do we do this. How do we evaluate this thingy? We could just go like this, but we could also go like this. If we were to go like this is divided by 6 divided by 2 times plus what is 2 times 3? 6. No, this is completely wrong. We didn't do the brackets. Okay, what about we did 6 divided by 2 times 8. If we did this, okay, this is a good thingy. Okay, we can do this, but example, we did not do the brackets first, then everything would be wrong. If we go like 6 plus 3 plus 2 divided by -3, if we did addition first, it would give us the wrong answer. Okay, when we do it in real life, when we kind of quantify this and stuff, blah blah blah, you would see, no, this is not how we should do it. We should not do addition first and somehow division, doing division first gives us the correct answer. This is why we all agreed upon doing BODMAS and stuff. Because of how maths is made, we need to do operations on a set order. Now remember, brackets is the first thing you need to evaluate. Whatever is inside the brackets, you need to use BODMAS again. And by that, let's do this. If there's no brackets, just follow these. Okay, remember, brackets first. If you do not simplify your brackets, you will be in trouble. Then it's this order, index, exponent, basically thingies with square roots or powers and stuff. You can simplify them to their numerical values, okay, in their decimal or or integer form. Next is divide or multiply. Okay, here in PEMDAS it is multiply divide, in BODMAS it is divide and multiply. Now, why are these two together and why are these two together? Okay, in this here, in this paragraph, all you can pause to read it if you want. All I'm saying is that divide and multiply, add and subtract, you need to remember to treat them as different things. Okay, as different levels, as you can say, of doing something. Okay, I do not really want to go in depth about what I mean by level and stuff. You can talk about this later in the video. But remember, for now, when we multiply, like example, when you do 2 over 3 plus 5 over 7, what are these two? These two are this is dividing by something. If we just add them together, like so, we get 7 or 10. No, this is not the correct thingy. Division is a different level, and addition is on a different level. You have to make the denominator same and then do it blah blah blah, like it's 14 plus 15 and divided by 21. Here is multiplication going on, okay, outside here, hence we have a common denominator, like so. I will explain it to you all when later on in the video what I mean. Now, it is common knowledge that, okay, before we go on, to be safe, evaluate it from left to right. Here I remember, whenever you have like a, a expression and all of the terms are in like same precedence, same level, so you can just evaluate it from left to right. That's the safest thing you can. If we go like, no, I want to do left first, then right, left, right, search between, it'll be a bit messy. Yes, we can do it if we are careful, but to be safe, okay, we want to be careful during our exam. Not only being fast in our exam, but being careful that we do not miss anything in our calculation and stuff. So we go from left to right. How to do the 4 operations among whole numbers. The following example has some tips. Yeah, last video I told you, I will tell you what to remember. I didn't. Yeah, sorry. So this is the cover up for here. Remember your times table up to 12 till 12. Example 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and up till 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up to 12 to 12. Yes. Not everyone, if this seems a bit too much, this will be just by practice, okay, but I do really suggest knowing our timetable up to 12 to 12. Okay, remember the squares of 1 to 12 and cubes of 1 to 10. Okay, what are they? 1, 4, 9, 16, 32, oh my god, 36, 49, 64, 81, 100, 121, 144. Heck, I even know 13 and 14. 140, 169 and 196, 225, this is for 15, and 256, this is for 16. I'm not showing off. Okay, I'm sorry. But till 1 to 12, then it's okay. I do test you recalling your 12, your 13, your 14, but you can do that with the prime factorization method that I told you in the last episode. You guys can watch the last episode if you want to see that. And cubes of 1 to 10, what are they? 1, 8, oh, I do not like this, 27, 64, 125, 216, 373, wait, oh god, 64, 8 times 8, 8 is equal to 64 times 8 is equal to 64, 128, 250, yeah, 250, 512, yeah, 512, sorry, 79 and 1000. Nice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my cubes. I know 11, 1, 3, 3, 1. I do not know 12. Yeah, that's this prime factorization. And example, you have this, and it's like in 12 cubed in numbers. You can just use prime factorization to do it. You know this number. You would get like 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 3, 3, 3, and then prime factorize it to get 12 cube root. Recall the commutative laws of addition and multiplication. Use them throughout to simplify equations, even for your calculator. Remember, you need to know your commutative laws of addition and multiplication. What are they? Remember, a plus b is equals to b plus a. A times b is equals to b times a. This does not apply for only two, but applies for many. Example, we have this half times 50 times 12. We can do this instead. This is what 5 times 6 is equals to 300. You can do this easily. You don't need to calculate 25 times 12. You can calculate 50 times 6 instead. This is the commutative property, because you can you can evaluate, like I said, in board mass, left to right. But if I'm careful, then I can do this. Like I can swap the order of 12 and 50, right? And then evaluate it from left to right. This is 6, and this is then 300. See how I'm using rules together on top of each other. This is what you need to practice doing, using rules on each other, using rules together simultaneously. This stuff. Okay, you need to have this as your thingy to quicken up your thingy. Now, I know if you are not that fast enough to recognize these things, it's okay. This comes with practice. I've done tons of practice, but you might need to do the tons of practices I will assign you at the end of the video as well. And it's a funny thingy. You know how plus times plus is equals to plus times minus is equals to minus times plus is equals to a minus, and minus times minus is equals to a plus. You guys need to know this. Pause the video if you want to revise this. Want to know about this one? Example, you are facing this way. You turn left, and you turn, and then you turn. Boom, you are facing in the same damn direction. This is why the negative works. Here we flip only once. Here we never flip. That's how the multiplication works. I've done this acronym if you want. A friend's friend is a friend. A friend's enemy is an enemy. A enemy's friend is an enemy. And a enemy's enemy is a friend. It's better people in Pakistan learn it by the using it in Urdu. So yeah. Next, now from fractions, we know how to do board maths with integers and stuff. Now with decimals. Now textbooks do contain doing stuff with negative numbers. For negative numbers, I highly recommend you always being careful and having a negative numbers in brackets. Okay, it helps out using this rule as well. Then it will do example. This will be the 4. In exam, you might not have the luxury of having brackets around negatives, but you need to be careful with negatives during your practice. Decimals. Addition and subtraction with decimals is as easy as aligning the decimal point and computing the answer. Example, you have 2.347 plus and we add 0.0729. Here we align up the decimals to 347 0.0729. Now here you can see my decimal places are not properly. So when you are setting up a decimal addition, please have your numbers in actual proper columns. Okay, please, so that you do not get lost at what are you doing. Here we get example 9, 9, 7, 8, 9, 10, 11, 4.2. So this is 2.4199. You do not need to use a calculator. It's just that you need to know how to do decimal. Okay. God forbid your calculator is being used by someone else in the examination. What will you do then? So this is why you should know how to add, subtract decimals by hand, but most likely you won't need to do it as often. Yes, you have to do it in estimation questions. I will come back to this later. Okay, in the estimations and accuracy chapter, and you will do it. And multiplication and division can be done by representing decimals as 8 or 10 to the n, where a is the digits and n is the number of digits. Example, when you do 3 times 3.3 times 0.19, we can represent them as fractions. Remember what I told you, we can convert between decimals and fractions. And here we can do 19 over 100. I think you may notice. If you not notice, look at like a Cognito video or something. We can convert these two into fractions and then multiply the fractions together. Multiplying fractions is easy, don't worry. I think I should have done this section before the fractions. It's okay, we can get to it later. Here, see division. Now, we will get to dividing fractions later, but you need to know this is how they simplify to get our answer. Fractions. Addition and subtraction with fractions is done by making the denominator same and computing. We can do this by multiplying the fractions top and bottom with the other fraction's denominator. Next, we simplify the numerator and denominators, then the entire fraction. Example. Okay, what do I mean? We have this addition of two fractions. What do? We multiply 7 on both sides and this on both sides. The denominator of the other fraction, we multiply it to the whole fraction. Next, the numerator, we get this. But in the denominator, you can see we are just doing 7 times 2 or 2 times 7. Remember, commutative property. So, you can just group them together technically. Remember your thingy, multiplication over addition. And you can do the reverse as well, vice versa. You can go reverse. Okay, we just went reverse like here. Okay, we just group the denominators together like so, like 1 times 7 plus 5 times 2. We just grouped it technically and go under like so. This is how we do it, this combining fractions. But then we just evaluate top and bottom like so, like nothing happened. Here I evaluate this also and we get this number. Why? 1 times 8 is equals to 8, 6 times 4 is equals to 24, and the bottom we get what? 32. Here on top you get negative 16. You can simplify this fraction, we get 1 over 12. 1 over 2, sorry. This is addition and subtraction of fractions. I hope you guys understand. Okay, remember, the reason why we combine the denominators is that multiplication or division is at a different level in addition. Same reason why multiply and divide are on different level in addition and subtraction and BODMAS. Remember, multiplying with fractions is done by literally cross multiplying the numerators and denominators and simplifying the fraction afterwards. Here we do not need to simplify the fraction. You can just do this like example 6 over let's do 14. Let's go with 13 times 69, I guess. Yeah, 69 over 2. We can cross multiply. We get a large number on the top and bottom, and we can simplify in the bottom. Obviously you would have a more easier numbers to multiply with in the non-calculator paper. Here we get 3 times 3 is equals to 9. Done. Division with fractions is done by changing the multiply into divide and flipping the second fraction and then multiply. Example, when you are dividing two fractions, what do? We use the keep flip change rule. Keep flip change, KFC. Yes. Keep flip change as in flip it. No, it should be KCF. Yeah, KCF, sorry. Keep, change, flip. Aha. Nice. I will explain it to you later. Later is like now. Example. You know the multiplicative identity. A times 1 over A is equals to 1. If we divide A on both sides, 1 over A is equals to 1 over A. This 1 over A is the same as A over A is equals to 1, dividing by A. So what do? When we divide this by this, it's the same as multiplying by the reciprocal of that. You multiply by the reciprocal of A here, you multiply by the reciprocal of this fraction. And this is why the keep change flip rule works. Next we have mixed fractions. A mixed fraction is represented by A, B, C. Here, normally, yeah, it just looks like a number with a fraction. What this represents is basically A plus B over C. Okay, I will tell you why in a second. But remember, it actually means this. In a calculator, it may look like this, like a small BC. So yeah, that's what we will see later on, where A is a whole number and B and C the fractional bit. Everyone is a whole number. Okay, don't worry, everyone is the integer. Everyone is an integer, but A is the whole part and B and C is the fraction part. You can think of it as like a decimal, like we have 1.25. This can be represented as 1 over 4. This 1 over 4 fraction is this decimal component, the fractional component. Okay, this literally means 1 plus 1 over 4, which is 1.25 in the calculator. This is how a whole number is represented. To turn an improper fraction into a mixed number, we do normal division, dividing the numerator by the denominator. The quotient is the whole number and the remainder is the numerator of a mixed number. What do you mean by improper fraction? By improper fraction, you mean the numerator is greater than the denominator. Okay, this is what we call an improper fraction, like this. And this is not a proper fraction, because a fraction is a part of a number, and that part, okay, normally the numerator would be less than the quote total, okay, the quote total, to represent that, hey, this is a part, this is 2 part 7. But here this is an improper fraction. This is like, I don't know, a random quantity. This can be represented in terms of a mixed number then. Okay, where this will become 4 2/3. Okay, this is the mixed number representation of the number. Let me explain how do we find mixed numbers. Example, we want to turn this improper fraction 15 over 4 into a mixed number. What do? We divide 15 by 4, okay, using long division. So we can see this comes in 4 times 12, subtracts first. We have a remainder. We cannot subtract further. Okay, this remainder over here, this remainder is this bit. And next, this answer that we have, the quotient, is over here, and the number we divided by is over here. This is a very bad example, but let me get another example. We have 25 over 7. Let's divide this, let's see what happens. So we have 7, 25. We can already see 21 counts, so we have 4 and 3. Let's now write it. Now 3 is the quotient. We'll write it as the whole number bit of a mixed fraction. Next, 4 is the remainder. We'll write it as the numerator, and the 7, the dividend, is the denominator in a mixed fraction. So we just converted it into a mixed fraction. This is how you can write it in a mixed fraction. Questions will tell you to compute a result, to compute something, and then turn it into a mixed fraction. Don't worry, we have questions in the same file as well. That's why the file seems a bit long. When in computation with mixed numbers, we turn it into a fraction, then give the answer as a mixed fraction. Turn a number, example a, b or c, the fraction, you multiply c to a and add b to for the fraction's numerator. You keep the c as denominator. What do I mean? Example, we have this. What we do is we multiply 6 with 5 and add 1 to it. So 6 times 5 is plus 1 is equals to 31, like over here we can see. And in this one we do negative 2 times 3 plus 3, so this is negative 20. Now you can think of this negative as like its own thingy. This is 20 plus 3 is equals to 23. Yeah, this is a very bad explanation, but remember, negative is just the sign of this mixed number. This bit over here, this magnitude bit of the mix of like a negative mixed number, this is what you will use. You will not use negative 2. No, you will not use negative 2. You will use normal positive 2 to compute it, because this negative will just say, okay, you're just converting the magnitude bit of this quantity here in the bracket. This is why I take the negative to be outside when I'm converting in the step. It does not count as an count. Okay, you can think of it as negative 2 plus 3 over 10. Now you will see, this is, you can say have the denominator be equal, and then we can see this is like so. Similarly over here as well, you can think of it as literally adding the fraction to this. Denominators will be same, and voila, we get this result. This is what the conversion from mixed to fraction means. Okay, see how we get an improper fraction after this. This is what I mean by to turn an improper fraction and vice versa, mixed number into an improper fraction. Next, we get our answer as a fraction, but this is improper, meaning likely a question may ask you, I want it to be a mixed. I want you to mix it up. Okay, so you do the long division and turn it into a mixed number, like so. Very simple. If you want to verify that your answer is correct, you can do the result in reverse and see that indeed the answer, the mixed number that you got is the one that we converted earlier. That's how you can check it yourself. Now, the theory bit is done. I hope you guys understood everything. To get a bit more understanding, I will do some questions with you guys. I didn't do them in the last video, I'm very sorry. So yeah, the 4 operators. You can pause the video to get the questions that I have in here. Okay, I will just zoom past them all, and yeah, have fun practicing, I guess, the questions that I gave you. Now, all of these are past papers. All of these are past papers, but they are in a random order. Yeah, random. I couldn't really decide what to do. Okay, these fractions, I really love finding out these things. Okay, like making these giant lists, because these are the ones that came in the from 20 to 25. All of the fraction questions that came. Okay, I may have plagued them with adding my own, but not in the fractions. I think done it in the next video's questions list. I added some values of my own because I could not even find any. Yeah, I needed to do this maneuver. Very big. Okay, do not be intimidated by the big question count. It says that every part has its own marks. That's fine. Board marks, we got some. Now, in the exams, there really isn't any decimal questions, like decimal computation questions. So, we will see decimal computation questions in the estimations video. If you cannot wait, you can do estimation topicals yourself, or go on with me to do estimation, because then there they will ask you to like add decimals together, this and that, all that fun stuff. Okay. Example, it also tests how we can rearrange this and that, this and like this place values. Here this 20, this is like over 10 again. So if this value is over 10, meaning this value should be over 10 as well. Why? Because multiplication is commutative and it should apply on both sides to keep the equality same. So this is 339.78. The next 397, this divided by this. Here we multiply this by 10 and multiply this by 10 all everyone. So it is what? 195 times 204 is equals to 3978. If we divide 3978 by 204, what do you get? Let's divide 204 on both sides. This cancels out, we get 195. So this is our answer. Oh, and also I do not have any answer spaces in this worksheet. You have to do them in a separate sheet also. There's also this. This really helps you get down your board mass rules. Okay. And this is like a very fun exercise. These will come in the exam. Okay, I do not want you guys to waste your head banging on the desk that how should I do it. You need to do proper practice as well of this. Even if it looks very simple, remember, it's the simple things that might make you lose it. Conversions, simple conversions, you guys can do it. 3/4. This is like some British thingy. 3/4 means 3/4, by the way. Okay. Some do need a calculator. Example, this is actually 1/16. 4/16. Yeah, so sorry about that. As a percentage, see, I repeated some as well. Shade 3/4 of this grid, 2/5 of this rectangle, 2/9 of this shape. Square so that both shapes have the same fraction shaded. Identity fraction that is shaded. Percentage that is not shaded. Okay, fractions to percentages, you got to use that thing. Shade 15% of the shape. Turn this into a fraction so you know what to do instead. Are not equivalent to this. Calculation is not equal to this. What do you have to do in here? Okay, what do you have to do in here? Turn this into a mixed number, into a fraction. We get 13/5. Now flip it. This is 5/13. Alright. Now, do you guys see the answer? Yes, you do. That is equivalent to 7 or 9. Anything. Just multiply both sides by any constant, you will find it out. The fraction that is this in simplest form, equivalent to this, and then some of these. For these questions, I went a bit overboard and went like from 2010 to 2025 year range. This is like very discontinued. Yeah, so that's why I went out of my way to see if Cambridge ever did more of these, and I was not Disappointed. I do not have this. Okay, I'm very sorry. You guys can skip this question. Okay, I will give you guys a free pass. Okay, free 2 whole marks. Literally, free 2 whole marks. We didn't have calculations without a calculator. All of them are non-calc questions. They do come. Okay, they were also like old. I think they discontinued this, but this is like good practice for you guys. I said every past paper, so why not do every past paper? Come on, guys. You guys can read this yourself. Let me do some questions for you guys before I leave you guys be cold in the dark. Okay, I'm gonna do like 1, 2, 3. Rajat has a full bottle of juice. He drinks 1/3 of the full bottle on Monday and 3/7 of the full bottle on Tuesday. Find fraction of the bottle of juice remaining. Now, we know the full bottle has 1 is like 1. Okay, because this is the total. Anything over anything is equals to 1 also. If we drink 1/3 on Monday and 3/7 on Tuesday, how much do we have left? Okay, let's see. This is 1 minus 1/3 minus 3/7. You can do board mass, left to right. So 1 minus 1/3, we get 2/3 minus 3/7. You can just do 3/3 minus 1/3. Have the denominator same, and we can find it down. Next, denominator same, we get 2 times 7 is equals to 14, 3 times 3 is equals to 9, 3 times 7 is equals to 21. 14 minus 9, we get 9, 10, 5. We get 5. Yes, 5. So you get 5/21. 5/21 is the answer for this question. I will put my working inside the area. Okay, 3 marks. Okay, 3 marks of something. I do not know how the marking goes, but it is 3 marks. Trust me. Rio buys some pens. He sells 63 pens, where 7/9 of the pen he buys. Work out how many pens he buys. So if 63 pens is equals to 7/9 of a quantity, what is that quantity? Okay, we can divide 7/9 on both sides to get what? 63 divided by 7/9 is equals to this. Remember, 7/9 times x, meaning this represents 7/9 of x. When it says find its fraction of a quantity, it means multiply that fraction by that quantity itself. We do this. 63 times 9/7. This is 7 times 9. So this is 7 times 9. So 7 we got 9 times 9 is equals to 81. Meaning he had 81 pens. How many pens he buys? He bought 81 pens and sold 7/9 of those pens. It is 63. You guys can verify this. 81 times 7/9 is equals to 63. Indeed. Ranjit buys some plants and sells 5/11 of them. He sells now 190 plants. Work out how many plants he buys. Okay, he bought and he sold 5/11 of the plants he sold. How many he sold? X. He sold how many? 5/11 of the quantity. And how many were those actually? 190. So how many did he buy? We divide 5/11 on both sides. X is equals to 190 divided by 5/11. So let's do this. 190 times 11 over 5. You can simplify this. You guys can do it mentally. 190. This is 100 and this is 90. 100 over 5 is equals to 20. 90 over 5 is equals to 18. 18. Add them up. I get 38. 38. So this is 38. 38 times 11 is 380. 38. 8, 8, 9, 10, 11. 418. So he bought 418 plants and he sold 5/11 of them. We get 190 plants. Let's verify our answer. Shall we? 418 times 5 over 11. We get 418. 11 long division, don't worry. 33. We get 3 over here. So this is 4, 3, 11. 11, 10, 9, 8, 88 minus 88 is equal to 0. 8, we get 38 as our answer. No, 38 times, okay, this is 38 times 5. Sorry, yeah, this is like cut with it. 38 times 5, we get 15, and this is 40, we get 190. Nice. You guys know how to add, subtract, right? Please. And yeah, I guess this is enough. You guys can now do the rest now that you know what the question means. Okay, doing word problems before doing actual problems gives you, a slight base of how you should tackle these. Sometimes I also have like simple things you can do this, like I got the difference between the temperature at midnight, which is negative 8.5, and at 11 a.m., meaning this is literally it. We get negative 8.5 plus 1 is equals to negative 7.5. This is the difference between these two temperatures. I'll keep the working, don't worry. Temperature at midnight was negative 8 and at noon is 6. So difference, what is the difference? This is 6 minus negative 8 is equals to yeah. Wait. No, I'm not. Yes, this is easy. I'm thinking about something else. 8, 14. Yeah, you guys might be wondering, why did I not do negative 8 minus 6? It gives us negative 14. The difference must always be positive. A difference must always be positive. So this calculation of mine is wrong as well. Actually, we should have done negative 1 minus negative 8.5. And then we get 7.5. Remember, the difference, you want to have difference between real quantities same. Okay. No, positive. Sorry. So my earlier calculation was wrong. This is the actual calculation we need to do. Our difference, okay, the difference should be a positive number, always. Okay, then you will get the correct answer. Here the difference, mine came out to be 14. If I did negative 8 minus 6, it come out to be negative 14. And you say, what on earth is negative 14 as a difference? No, you cannot have a negative difference. So what do? We try to get our answer to be positive. If our answer is coming out negative in the first computation, in the answer space, like here it will be like the dashed line, and just put the positive version of the answer. Boom, it's okay, because you guys know what it is. Temperature at 7 is 5 degrees higher than the temperature at midnight. Look at the temperature at 7 a.m. What is the temperature at midnight? Negative 8. The temperature at 7 a.m. is 5 degrees higher, meaning we add 5, meaning it is -3. Nice. At work out the temperature at midnight. At noon, the temperature is in Missouri is 21 degrees. At midnight, the temperature had fallen by 26. 21 minus 26 is equals to -5. Yes, -5. Not worry, you can do this carefully also. To know how to get, why do we get a negative answer? Look, you see this is a bigger number. You guys can temporarily switch this and we get 5. Then you have to just put on a negative. That's how we do negative addition subtraction. Okay. The average temperature at the North Pole is this. I think three questions are enough. You guys can do it on your own. Okay. Here we have table questions, which are self-explanatory. These fraction questions, you have them also. It has been a long time since I paused the video for to cool off. What were we doing? Solving some fraction questions. I will solve some and then you guys can do it on your own. Yes? Okay, good. Let's do this. Cross multiply, we get 99 minus 36 all over 18 times. Why are we doing this unnecessary job? We can just multiply this by 2 and we can get our job done. Yes, you guys can do this. Okay, I tend to not do this, but I do it when I can see a better solution. Okay, a better way than to multiply big denominators. Okay, this is when I bust out this method. Okay, hence I tend to cross multiply unknowingly. Okay, when I'm like lazy. Here you can do this method the same. The denominators will become the same, 18. Here we have 11. This is untouched, and then negative 2 times 2 is equals to 4. 11 minus 4 is equals to 7. So this is 7 over 18. 7 over 18. I hope that's your answer. Next we have this. Now we cannot do this with mixed numbers. If we do this 5 over 6 plus 4 plus 1 over 4, you cannot just divide a addition. You cannot divide a addition, because remember, what did I tell you? Addition and subtraction are different from multiplication and division. So you cannot do this like this. So you have to turn them into a fraction, then we can do it. Now let's turn it into a fraction. This will become 2 times 6 is equals to 12 plus 5 is equals to 17 over 6, and divided by 4 times 4 is equals to 16 plus 1 is equals to 17. Next we can flip this fraction. 17 over 6, keep, change, flip. 17 cancel. This is 3, this is 2, and the answer is 2 over 3, like so. So this is equals to 2 over 3. Now as a fraction in its simplest form, this is why we simplify the 4 over 6 point. Next, board mass. Board mass means we do this first, then we do this first. So remember, this, you can think of this as a negative 2 over 3. 5, so this is 5 over 6 plus negative 2 over 3 times 3 over 8. You can think of it like so. Okay, so you do not get confused. Remember, negative, a minus acts as a negation and also as subtraction as well. So you have to be mindful of what is it representing. Here it represents both negation and subtraction. We pull out we pull out this ambiguity by representing this bit like so that it represents negation by making the number a negative. On the number line, okay, here is the positive and here's the negative. Okay, if we just have this, it is this, subtraction going here, but this means the number is somewhere over here in the negative part. Let's do this. Now first the multiplication. 2 times 3 over 3, 3 cancels out, 2 over 8 is equal to negative 1 over 4. 5 over 6 plus negative 1 over 4, we get 5 over 6 minus 1 over 4, and we can do this easily. 4 on both sides, 20, and this is 6 on that side. 6 times 4 is equals to 24. This equals 14 over 24. We can simplify this to be what? 7 over 12. Sorry, not 17, 7 over 12. Voila, this is our answer. I'll do one more question before we move on to the next. Here we have this division over here. So it is 1 over 3 times 6 over 7. No, please stop. I know you can do this. No jokes in the comments. 2 over 7 plus 1 over 5, and we can do this. Cross multiply. We have 10 plus 7 all over 35. This is 17 over 35. We cannot simplify this further, and so this is our answer, 17 over 35. Very easy. Let's use board mass and it'll be good. Now here the marks are a bit weird. They just represent 2 different marks of each. Okay, if your teacher is marking this, yeah, do not give it to them. You guys can give it to me for to check your answers. Don't worry, I do not have the marking scheme, but I can deduce the answers and then see that how much marks you get. Now for the mixed numbers. Here this is simple. Turn it back. That simple thingy. But what does it mean to mixed number in its simplest form? Let's do one of the questions. Here is this. This is 9. 18 plus 17. 18 plus 7 is equals to 25 times 5 over 6. This cancels out. We get 5. This cancels out. We have 2 over 3. 5 times 3 is equals to 10. 3. Now we have the answer. This represents what? 10 over 3. But we need to fix this. So we can represent it as a mixed number. You guys can do this yourselves. I just instantly do it in my head because I have practiced. Yes, you guys can get this skill also. What I did was see how many times does 3 go into here. 3 times. So this is our quotient. What are we left with? 1. So that is our answer here. Everything I do quickly. Okay, I also wish you guys can do it also. You guys should know how to do it slowly as well. Okay, it's nothing bad in being slow. It's just that you got to be careful. That's the topmost priority. 3 or 4 times this is 3 for 5, and we cause this, we have 5 over 4. It goes in once, so you get 1, the remainder is 1, and we go and you get 4 like here. So this is 1 over 4. Here we have 4 over 3 plus 7 over 4. We can add the denominators. Have the denominators the same. Is 16 plus 21 all over 12. 16 plus 21, 37 over 12. Now you can see this carefully. 12 goes in 37 how many times? 3 times. So our remainder is 3, quotient is 3, our remainder is 1, and our dividend is 12. This is how you can do these very easily. Next, these, like I told you, off means multiplying. Let's multiply. 180 times 2 over 5 is equals to some value. I can do this by is equals to 10 over 2. This is 36 times 2 is equals to I'm not using a calculator. Okay, please. I'm not using a calculator. This is 12. 3 is equal to 6. So this is 72. 180 over 5. You guys can do this yourselves as well. This is 10 and 15. This is 3. We get 30 minus 30. 0, 6, and this is our answer. Very simple. Very simple. So this is 72 as our answer. You guys can do it remaining. I did it centimeters as a fraction of 2 meters. Now, this requires you to know conversion factors. If you do not know conversion factors, it's okay. It's okay. I can skip it for you guys. Oh no. You guys should know your conversion factors. I will then later on when we do rates, we will revise conversion factors as well. So you guys should know your conversion factors right now, or just have it at the back of your mind. I'll do this question for you guys. 3 over 4. How many grids are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20. 3 over 4 times 20. What do you get? We get 15. Aha. So you shade 15 and 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we can shade them equally, like so. If you guys are an artist, you guys know how to shade it better than me. But who cares, just shade it. And with a light pencil. Okay. Shade. These are easy questions. Yeah, so I guess you guys can figure it out yourselves. What do you have here? This is Ada's method to work out. This is without using calculator. Show how to use Ada's method to work out. This is without using a calculator. Let's see what they did. 99 times 27 is equal to 100 times 97 minus 27. We get this, we get this. So let's do it here also. This is 99 times 68 is equals to 100 times 68 minus 68 itself. So you get 680 minus 68. We get 8, 7, 10, 9, 10. We get 2, 3, 7, 6, 6, 7, 3, 2. This is our answer. 6, 7, 3, 2. You have to show your working. I will have 1 mark for your working and 1 mark for the correct answer. Remember. And this is how you can do the remaining. And obviously this is blah blah blah. I hope you guys have fun. Oh god, sorry, my tablet. Have fun revising and stuff, doing this worksheet. If you guys cannot do this worksheet in like one day, it's okay. Let's do like a mix of questions, like 5 questions in this section, in this section, in this section, blah blah blah. You get your thingy practice going. Okay, so you know how to do each type of question in what way. Remember, both. Okay, all of these questions are from both papers. Paper 1, from calculator and from non-calculator. So you guys need to know how to solve calculator and non-calculator questions. Okay, these earlier chapters will have questions which are very easy, which do not require a calculator at all. But later on, we may get questions which sometimes you may need a calculator optionally during their working, and the rest of the working will be like very easy doing it by hand. Okay, so you have to be mindful of that. So thank you guys for watching. Like, subscribe and share, and goodbye.